All right, substitution. This is a section that is repeated in your next course. So you take this in this class, and then in the next course, actually, it's the first thing you start with, depending where you are. In Pasadena, we don't, but at Cal Poly, you start this one more time. Here, they call it section 5.5. In the volume 2, it's called section 1.5. It's literally same numbering, same problems, word for word. So techniques of integration is pretty much what we do in the second semester calculus, but in the first semester calculus, we always start with one of those techniques because it's the most straightforward. So we have 5 main techniques of integration. We have substitution, integration by parts, integrals of trig functions, trigonometric substitution, and partial fraction decomposition. We're going to focus in the first semester of calculus, we focus just on substitution. That's it. The remaining 4, that will be the very first thing you do when you start your second semester calculus. And those are not going to be fun. This is fun. So this is how it works. You're trying to undo the chain rule. You're trying to integrate, and I know you don't see it yet, but f of g of x times the derivative of that. G of x is differentiable and f is continuous. So what you do, you say, look, let u equal that f and take a derivative of that. And you notice that integral simply become f of u and g prime of x dx is simply your du. And you go, okay, well, that's, oh, actually, I don't know why I use different colors. There it is. It was green. I thought it should be. So, let me tell you how it works. This is straightforward in the sense of you let u equal the inside of a power function, as you see in this case. The inside of a power function. You let u equal the inside of a radical. That's a power function. You let u equal the denominator of the fraction if there are no power functions. If you don't see any power functions, say, okay, do I have fraction? Let u equal the denominator of that fraction. Now, later on, when you do logs, exponentials, trig, you let u equal the angle if you don't see a power function, unless you see sine and cosine, because, you know, derivative of sine is cosine, derivative of cosine is sine. And we'll see all of these examples coming up. But when you do inverse trig functions, logs, and exponentials, if it's an exponential, you let u equal the power of an exponential. Now, logs and inverse trig functions are a special case. If you see a log and an integral, or an inverse trig function, you must let u equal that. That's how you start the problem. Now, that's not going to come up for us yet. But for now, again, the inside of a power function, the inside of a radical, which is a power function, the denominator of a fraction, if you don't see a power function, and if you see sine and cosine, secant and tangent, well, you know how it is. Derivative of tangent is secant squared, derivative of sine is cosine, and so on and so forth. So looking at this, I would start by saying, you know what, I see the inside of a power function. So the alternative to this, if you decided, you know what if I don't want to do that? Well, that's easy. Multiply this, distribute that, FOIL that 10 times, multiply it by t and integrate. You get the answer. FOIL this 4 times, or 400 times, or 4,000 times, and then integrate, and everybody's happy. Well, this allows you to avoid that. What you do, you let u equal the inside. U equal 1 minus t squared. Take a derivative of that with respect to t in this case. That's negative 2t. Now, if you cross multiply, and you're going to do that every time, you'll say, well, look, I see t dt right there. So what I'll do, I'll switch from t to u. I let u equal the inside of that 10 there. Now the blue part, if I'm off by a constant, that's an easy fix. The blue part, t dt, is simply du over negative 2. So if it's a constant and you're multiplying, whether you're taking a derivative or integrating, you could derive up front or pretty much do the differentiation, multiply the result by 1/2, or integrate, multiply by negative 1/2. Well, we know what this is. This is a power function, and we did this already. We know that the integral of x to the n plus 1 dx, oops, just kidding, x to the n dx is x to the add 1 to the power, divide by that, if you recall, plus c, assuming that n does not equal a negative. That was the deal of antiderivative from section 4.9, I believe. Well, we know what that is. That is add 1 to the power, divide by that. So that answer is negative 1 over 22. And that will be u. What was u? It was marked in yellow up there. That was 1 minus c squared. And that's pretty much it. And that's how it works. First example is tough as well. No worries. We're going to do just few more. Just few more. And we'll get the hang of this. Okay, here's another one. Well, let u equal the inside of a power function. Now, most of the time you're going to be off by a constant. I mean, this part will look exactly like that. You're off just by a number. You could divide both sides. It can be a variable. It has to be a number. If it's a variable, then that's the next semester. Then we use integration by parts. And you take a derivative. In this case, with respect to x. Well, that's just 7. Cross multiply. Now, I let u equal the inside of that power function. I need a dx. There's a 7 standing in the way, not an issue. Algebraically, I could divide if I'm off by a constant. That's simple. I'm going to replace this dx by du over 7. Now, there's another way of writing it, but let's stick with this. There's another way of doing this slightly different. Well, the 1 over 7 I could drag up front. That's 1 over 7. And wouldn't that be add 1 to the power, divide by that? So that is, either you write 1 over 35 times, or you put that parentheses to the 5th all over 35. It makes no difference. Put u back in and everybody's happy. So you always have to go back to x unless you see a definite integral. Whoops. Unless what you're looking at is a definite integral, and that's coming up, then you don't have to go back to x. And here's another. I see a power function, and the power function here is the sine. If I let u equal the sine of theta, so the inside, not the whole power function, the inside of the power function. And if I take a derivative, in this case with respect to theta, that's cosine of theta d theta. If I cross multiply, well, that's simply add 1 to the power, divide by that. Now, I didn't mention, but here I'll show you. Put u back in. Now, You could always check your work. Taking a derivative is a lot quicker. If you take a derivative of this, you should get that. If I take a derivative of that, you take the 1/8 out of the picture. You bring the power down, subtract 1 from the power, times the derivative of the inside. The 8's cancel out, and you're left exactly with what you started. You could always do that. You could always check your work. That's really quick. If I go to the previous problems, either of those doesn't matter. Let's say I take number 272. If I want to take a derivative of that, well, I could check. Leave the -1/22 out because that's a constant. Derivative of this, bring the power down, subtract 1 from the power, times the derivative of the inside, which is -2t. Of course, the derivative of the constant is 0. Well, negative times a negative is a positive. 22, 2 times 11 is 22. That cancels the 22. You're left with t times 1 minus t to the 10th. Right there. You can always check your work. It's very quick to do. Taking an antiderivative is a lot of work, but taking a derivative is much quicker. So every time you get an answer, you could take a derivative of that and figure it out. Now here I'm looking at what should I let u equal. Well, again, I see two power functions, but the outsidemost function, I see the cosine of t cubed. And if you let u equal t cubed first, that works, but then you need two substitutions. The inside of this power function, that's my u squared. And if I take a derivative of this, that is negative the sine of t cubed times 3t squared. So du, if I cross multiply, is negative 3t squared sine of t cubed dt. Well, let's see. I need a sine cubed of t, it's right there. I need a t squared, it's right there. And a dt is right there. I'm off by a constant, that's a simple fix. I can be off by a constant, not a variable. So I'm going to replace all of that mess by du over -3. That is negative 1/3, add 1 to the power, divide by that. That is negative 1/9 times u. Well, u was the cosine cubed of t cubed plus c. All right. How about this problem? So I'm going to touch on every possible scenario you can ever think of. This is one of the most important first steps in integration. Okay, well, here we go. If I take a derivative of that, that's negative 2x. And if I cross multiply, so instead of doing this, I'm going to start doing this. When you take a derivative, du will be negative 2x. I'll just put the dx since I'm going to cross multiply every time. Now here I notice the problem looks slightly different. Something's not adding up, and let me show you why. There's u. I need an x dx. I notice there's no x dx. What I'll do, I'll split this up. I'll say, look, x cubed is x squared times x dx. This is simply this. So I could replace that blue part with a du over -2. But we have a problem. There's an x squared left. Well, I need to get rid of all the x's. I can't have a du and an x. So I have to come back to this and say, okay, I see an x right there. What does x squared equal? If I swap those, wouldn't that say x squared equal 1 minus u? Okay, rarely happens. It's going to happen on your very first homework problem. The very first problem on the homework is going to happen, which is why I suggest you start with the second homework problem and come back to that at the end, or just tackle it. Now, what does that mean? That's negative 1/2. So this takes me to something we did before. That's 1 minus u du over u to the 1/2. That's negative 1/2, 1 over u to the 1/2 minus u over u to the 1/2 du. That is negative 1/2 times the integral of u to the negative 1/2, and 1 minus 1/2 is 1/2. We know this from before, algebraic manipulation. That is negative 1/2, add 1 to the power, divide by that. Dividing by a fraction is the same as multiplying by the reciprocal. Add 1 to the power, divide by that. Instead of dividing by 3/2, you multiply by 2/3. Don't forget the plus c. So if you distribute that in, that's negative. What was u? It's marked in yellow up there. Minus 1 is 1 minus x squared to the 1/2. And when we multiply that, that becomes a positive. The 2's cancel out. 1/3, 1 minus x squared to the 3/2 plus c. That's what you take a derivative of to get x cubed divided by the square root of 1 minus x squared. Again, this rarely happens in this class, but it does happen in the next course a bit more than you like. How about this problem? Well, the same deal. I look at this, I say, look, I'm going to let u equal the inside of a power function. I'm not going to multiply 1 minus cosine of theta, FOIL it 99 times, u equal 1 minus the cosine of theta. If I take a derivative of that, I should say du d theta, but let's say now du equal derivative of cosine is negative the sine, so that's a sine of theta d theta. Right, let's just skip in that middle step. Well, let's fill in the blanks. I put a u right there, and that u is raised to the 99. I want a sine of theta. I got a sine of theta. We have an issue again. It already happens. I need a cosine. I know what cosine equal. I go to the very first substitution and say, look, if I swap those, cosine of theta equal 1 minus u. And the reason that's significant, I switched a into b plus a into b plus c to the 99 is very hard to do. L plus m times n to the 99 is easy to do. You just distribute. But here you have to FOIL first. Notice, if I wanted to simplify this algebraically, I have to FOIL this 99 times first, then multiply that by those two. Here, all what I have to do is distribute that in. That's u to the 99 minus u to the 100 du. Add 1 to the power, divide by that. Add 1 to the power, divide by that, plus c. And u was marked in yellow. Don't lose track of that. It's up there. That's 1 minus the cosine of theta to the 100 divided by 100 minus 1 minus the cosine of theta to the 101 divided by 1 plus c. And if you take a derivative of that, you can guess what you're going to get. You're going to get u cosine times sine into 1 minus the cosine of theta to the 99. This problem, the same deal. I see a power function. I know exactly what to do. I'm going to let u equal the inside of the power function, the cubic right there. I'm going to let u equal that. If I take a derivative of that, bring the power down, subtract 1 from the power, right? Bring the power down, subtract 1 from the power. Oops, I forgot the chain rule. You guys should say something. du will be, bring the power down, subtract 1 from the power, times the derivative of the inside. Bring the power down, subtract 1 from the power, times the derivative of the inside. Now, I noticed that I need a cosine of theta times both of those. Well, I see there's no constant. If I factor a 3 and a cosine of theta out, so I'm trying to make it look exactly like this. That will be a sine squared of theta minus twice the sine of theta, and they both have a d theta. There it is. I notice now the blue part is right there. All what I have to do is divide by a 3, and I could replace all of that mess by a du over 3 and integrate. Well, I know what that is. That is 1/3 the integral of u to the third, add 1 to the power, divide by that. So that is 1 divided by 12 times u to the 4th plus c, and u was marked in yellow up there, highlighted, or my first assumption, if you can't see that color, the first substitution. Okay, third time will be a charm. And there it is. Take a derivative of that, you'll get all of that mess. Now we go to definite integral, and here I want you to start paying attention to something we're going to do that we didn't do before. I might have touched on it, but now we want to make it official. So, if it's a definite integral, in case you're wondering, this is an indefinite integral because there's no limit, and you always get a plus c on it. We only have 2 types of integrals. This is the definite integral because we have numbers right there, and that means you don't get a plus c. That's simply f of 1 minus f of 0. Well, I need to know what capital F of is. What do you take a derivative of to get this? This has a power function. That's the first. So when you get to the next class, every time you look at a problem, you try u substitution first. Always. Take a derivative. Well, this is going to be the integral. The square root of u. And x dx is simply du with a -2 in the, so -1/2 that. Now, there is a small change. The problem is, I want to write these units. I can't write 0 to 1 because if you know, if this is the x, that's x equals 0 to x equal 1. If this is a du, then that's u equal to u equal. Well, let's see. If I throw a 0 in for x, wouldn't u equal a 1? And if I throw a 1 in place of x, 1 minus 1 squared is 0. And I'm going to do that on the next problem and the next one, right? And we'll see how that goes. That would be -1/2 the integral from 1 to 0 of u to the 1/2 du. That is -1/2, add 1 to the power, divide by that. Now here I'm going to evaluate it from 1 to 0. I don't have to go back to u again. I don't have to substitute in the yellow part anymore because I changed the limits on the integral. You can only do that if you have a definite integral. The 2's cancel out. That's -1/3 times, throw the 0 in, throw the 1 in, and of course 1 raised to any power is 1, so the answer is 1/3. And if I would not have made the change on the limits, if I would not have put 1 to 0 there, then I would have went about it and said that's the integral of square root of u. I just did that, -1/2 du. I would have said that's -1/2 u to the 1/2 du. The work doesn't change. Add 1 to the power, divide by that. And I would have said that's negative 1/3, but I would have said, what does u equal? 1 minus x squared. Evaluate that from 0 to 1. Again, assuming I didn't change those limits. If I just wanted to do it like I did the previous problems, you can. But then you're going to plug in the 1 in. And 1 minus 1 is 0 to the 3/2. Minus, you're going to put in 0. 1 minus 0 is 1 to the 3/2. And there it is. But I strongly suggest that you change the limits and the integral. In this class, it'll save you 1 step. In the next course, it could save you anywhere from 3 to 5 steps, especially when you do trigonometric substitution. Here's another one. What should I let u equal? The inside of a power function. I see one. That's a power function. 5 plus t squared. And du will be 2t dt. I should practice. Put a 0 in there. 5 plus 0 is 5. Put a 2 right there. 2 squared is 4 plus 5 is a 9. I don't have to go back to the yellow part. Now it's just an integral in terms of u. I'm going to evaluate that with the 5 and the 9 and never look back. Well, that is the 1/2, the integral from 5 to 9 of u to the negative 1/2 du. That's 1/2. Add 1 to the power, divide by that. That's simply square root of 9 minus square root of 5. That is 3 minus radical 5. Again, you could have just went back and put in 5 plus t squared in there. Evaluate that from 0 to 2. You'll get exactly the same answer. I strongly suggest you start doing that. How about this problem? What are you going to let u equal? You're going to let u equal the inside of a power function. The inside of the power function here is the secant of theta. If you let u equal that, that will be a u squared. Derivative of that is secant of theta tan of theta. Well, that didn't work properly. Then what? Well, I could write this as secant of theta times secant of theta tan of theta and change that. Say, okay, let's just u equal that. And du is right there. That works. And if you didn't like this, not a problem. If that didn't work, the shortcut that I told you, then hey, go back, say, okay, well, there's only 2 things. I let u equal 1, it didn't work. What if I let u equal the tan of theta? Take a derivative. What's the derivative of tangent? Is secant squared of theta d theta. In this case, if I pick the blue, there. Now, which one you should choose? They both work. But since we're doing just a traditional u sub, let's stick with, okay, what works, really the first attempt. If I let u equal, the inside of the power function didn't work, so ignore that. Let u equal the other piece, sometimes that happens. If I let u equal tangent, du is right there. Now, if I let that be 0. Tan of 0 is 0. If I let theta equal pi over 4, tan of pi over 4 is 1. That is u squared over 2 evaluated from 0 to 1. And we know what that is. Plug the 1 in. That's 1/2 minus 0, which is 1/2. Oh, and that's pretty much it for this section.